Hello everyone. In this video, I would like to address a very important topic which is making a very big question in the minds of a lot of people in the world, whether this horrible corona crisis will go down when the temperature goes high in the summer. So of course the summer is coming in the northern hemisphere, and also the winter is coming in the southern hemisphere. So the topic of this video is whether what will be the effect of summer on the coronavirus production, and whether coronavirus crisis will go low or high, or what will happen. First of all, I would like to tell you that I don't know whether COVID-19 will go down or up. So I will give you an example from another coronavirus, because coronavirus has many types. So there was another coronavirus outbreak back in the past. So scientists did research on it and tried to find out what happens when there is different humidity and temperatures, and what happens to the viral reproduction and the effects on the outbreak. So right now many scientists in the world are thinking what will happen when the temperature goes high or the humidity goes high, whether we will get safe or not. Some people are saying maybe we get safe, some people say we don't know. So let's see. So the purpose of this video is just to read that paper regarding another type of coronavirus and see what results they bring out and what are the important consequences of that research. So I'm talking from Germany, and I wish everybody is safe. I know this is a very hard time, so yeah, good luck and my best wishes to everyone. So let's get started with this paper. So first of all, guys, the thing is, in this paper, this is from the University of Hong Kong, Department of Microbiology. So what they have done is they have performed different experiments. They have performed different experiments and check under what type of condition what happens to this SARS coronavirus. And so far I have found this paper to be the most interesting one and the most good one to read and get some intuition from it. So I will not go into too much details about. I know many people are not familiar with microbiology and complicated terms, so I will just discuss its results, which are important for journal people. So the first thing is that they performed different experiments. In the first experiment, what they did was they kept the virus on some surface, and in another experiment they put the virus in some sort of a wet in a solution, right? And then they increase the temperature. And so what happens, and this RH is the relative humidity. So the first experiment means that what happens to the virus when it's in the solution form, and what happens when it is in 33 degrees centigrade relative humidity, which is quite high, like 95 degrees centigrade, and what happens when the virus is in the dry form, 38 degree with relative humidity greater than 95%. So the thing what this saw was that when the virus is in the solution, and it takes a very long amount of time to get reduced. So this axis show reduction in the virus load. So it means the greater the value, the better it is. So it means if you look at the red curve, it goes it remains for long time active, and after a very long days, like almost like I don't know, here it's like 21 days it goes dead, let's put it this way. The other case is when the virus is in the dried form. So the dried form is considerably better than the wet form, but not so it again goes here, it goes on and on and on, and it get destroyed after, let's say, 7 days, 13 days, and something in this form. So this is the blue curve. So of course blue curve is better than the red curve. And then we have the case when we have the virus at 30 degrees centigrade, relative humidity greater than 95%, and the second case is when the relative humidity, the temperature is 38 degrees. So this is the most important result, and I would like to talk about. So here one can see if the temperature and relative humidity goes high, the virus is killed very fast. So it means that even in 24 hours virus has suffered a lot of damage here, right? So higher temperature, higher humidity is very, very good thing, and it is a very, very bad thing for virus, which we all want. Similarly, if just there is a 5 degrees centigrade of difference, again the virus life is extended. It is not dead, as we can see. It goes like 24 hour, and relative deadness is not so high. It's just the value of 1. So the bottom line of this result is the key takeaway, that higher temperature and higher humidity is the best thing, and ideally in the dried form. So this is the first result of this virus, of this study. And this study is important because suppose you are living in countries, for example, like I don't know, like Malaysia or Indonesia or Thailand. So these countries have very tropical weather. They have very high temperature but high humidity. So these countries have less community outbreaks, because in some form they are obeying these two curves. So they are getting benefit from this curve. This is the main thing they are getting benefit from. Said they have high temperature, high humidity. Okay, they are little bit less, so the net effect is the combination of those two things. So the bottom line is that these countries are somewhat better when they have a coronavirus outbreak. I'm not talking about COVID-19, but some form of other coronavirus, which was this SARS virus. And then when we talk about countries like Hong Kong, which is not really tropical, it is like a subtropical thing. So here the temperature is a little bit less, humidity is a little bit less, and they have so they have quite bad situation, because the virus gets good condition to live here. And so this is not good. This is not good. And so Hong Kong, in simple words, Hong Kong type of temperature is not good for SARS coronavirus, while Malaysia, Indonesia, Thailand have better conditions. So this is one of the key takeaway from this study. And then when we go further, so here again some experiments are done, like on 28 degree, 33 degree, 38 degrees, and here we can also see that 38 degrees is the best to kill the virus. The curve goes very sharp. A lot of killing is happening. Let's say a killing of 2 times and 3.5 times. I'm just saying for intuition. So a lot of virus reduction is happening. So higher temperature is very, very good, and it's very, very bad for virus, which we all want. Similarly, this curve is the same family of curve. So in terms of humidity, again, high humidity is a very good thing. So here we can see this the curve A is the high humidity. So high humidity is very bad for the virus. So higher humidity and higher temperature. So this was the main thing, the main conclusion from this paper. Now the question comes, what will happen to COVID-19? Again, nobody knows, but based on this study, as we move towards the summer, and I pray that everywhere in the northern hemisphere, also in the southern hemisphere, also India, Pakistan, Germany, Sweden, England, America, everywhere this virus goes around, because this a dangerous machine is killing a lot of people, and it's a horrible thing in human history. So one can hope this will go down, and this study is a very good study. I personally believe on this study that the virus will definitely go down, but again, you should follow the advice of your health authorities and stay safe. Thank you very much.